Good morning. My name is Erdre Cerezon, and I can recognize some faces that are familiar. I'm structures expert in certification. Today I'm located in CT3, which is a VTOL department, but like my other colleagues of structures, I'm working cross products on large airplane, rotorcraft, and general aviation. So today, the purpose of this presentation is to share with you a certain level of awareness on environmentally assisted cracking. I thought it was important for STC holders to know about this topic and this issue, because basically by doing STC, you can be led to use those material or to alter the materials that are actually part of the type certificates. So back in 2004, there was an international conference on aluminum alloys, and I think that they have a yearly conference on this topic. But the aluminum manufacturers has presented a new generation of 7,006 section alloys. This new generation of alloys was very interesting for industry because they are presenting a low quench sensitivity and high strength toughness capabilities, and they were advertised after having performed long-term laboratory tests on this 7,000 series. And in order to anticipate the weight saving that was very important for their product success and development, industry has actually engaged aluminum alloys manufacturer in bespoke development, and new generation of 7,000 series alloys have emerged from this investigation and those developments. Some years after type certification with those alloys, first cracks were found, and they are actually found in a short transverse direction. Basically, you have on these pictures some roll and extruded rods and thin shapes. So I could use a pointer eventually. Yes. On those bars, basically, the short transverse direction is the one that is shown here. On those thin plates, the short transverse direction is basically the thickness directions. So on more conventional shaped parts, let's assume that this is spar, or it can be a frame or a stringer. So no matter if you have L shapes, C shapes, the cracks are actually appearing starting from fastener holes, and they are appearing in the direction, in the parallel direction of the stress, which is actually, they are supposed to develop under fatigue in the perpendicular direction. But this is absolutely, it has nothing to see with fatigue. So starting from the fastener holes, cracks are developing in the direction of the yellow line. So going from one rivet to another. So while the prone direction from crack growth is this one. So this was actually quite surprising at the very beginning. Basically, it was identified that this issue was actually not, it was known, but not so well known. So this issue is actually a form of environmentally assisted cracking. And this form of cracking developed on susceptible material, so the new material that were developed due to hydrogen embrittlement. So environmentally assisted cracking is a general terminology covering several phenomena. But this form of cracking is actually appearing when you have the susceptible material. It is due to hydrogen embrittlement, and actually it is happening in the normal operating environmental condition under sustained stress induced by manufacturing. And when doing a fractographic analysis of the cracked material, you see those patterns. So considering that is your left, on your left hand side, you have actually EAC, which is a failure of at the grain boundary, while the grain itself is not so damaged, let's say. This is due to hydrogen embrittlement on the solid metal. The next picture is stress corrosion, conventional stress corrosion, that is not only affecting the grain boundary, but also the grain itself, the grain capability itself. So this is how EAC, due to hydrogen embrittlement, is differentiated from the conventional stress corrosion. So today, in the airplane industry, we usually use stress corrosion standards to evaluate EAC. So the conventional standard is the ASTM G47. And this is done in very severe atmosphere, salty atmosphere. And this standard actually didn't exhibit the kind of environmental aesthetic cracking generated by hydrogen embrittlement. Actually, it's tend to mask it. On this slide, you can see a list of material showing which reference of material are sensitive to EAC, this form of EAC. And as you see, they are zinc-based alloys of the 7000 series. From yellow to red, you have the range of sensitiveness. And you need actually 3 parameters to exhibit this issue. First of all, to have the susceptible alloys. Second of all, to have sustained stress in the short transverse direction. And the third parameter is some level of environmental condition, humidity, and it gets developed with time. It's not related to cycle, nothing to see with fatigue. It's really exposure and time related. So I wish to clarify that you used to, STC holder used to apply a zinc-based aluminum for airplane and rotorcraft industry, and it was so far very successful. The point here is that those particular alloys have a high ratio of zinc magnesium, a low rate of copper, and they are sensitive in very specific windows when combining zinc ratio, zinc magnesium ratio, and copper content. So what we try to bring awareness on the EAC sensitivity, but it doesn't mean that every 7000 series aluminum have a problem. So it is really dedicated to those specific modern zinc-based aluminum alloys. Combining those 3 factors. So I must say that originally we thought at EASA that this problem was affecting only one STC using a specific aluminum alloys, but we realized sometimes later that the alloys manufacturer has provided to widely aluminum of similar composition with some variation to other industries. And this is the reason why 2 or 3 years ago, we have issued an EASA SIB on the topic. 1 year after, we have, so in 2018, we have issued a revision of this SIB. SIB stands for Service Information Bulletin. And this new revision was offering actually a test method, allowing to detect when the aluminum is susceptible to EAC. It's a severe test method, and we were, this SIB was heavily commented in this direction, but at least it allows to know if you have a problem or not. So from the publication of the SIB, we have received some comments, and we could identify the products that are affected or could potentially be affected by this issue. So 3 large airplanes has been identified, 2 rotorcraft, so large airplane and EU rotorcraft. 2 foreign validation products were also identified, and some military products. So based on this discovery, basically we have encouraged TC holders to develop continuous awareness actions, corrective action, essentially based on risk. And we focused our attention on PSC, so primary structural element. So you have on EASA website this SIB, which is available, so you can have access to it. You just have to dial environmentally assisted cracking on Google. So now, basically, we think that we know pretty well who is affected, but if you have any of those materials in the composition of your STC, or if you are led to modify a structure with those material, you have to know that there is an issue, and you have to evaluate what could be the consequence of this alteration on this the structure actually having those materials. So at the EASA level, we try to encourage the TC holder concerned by this potential issue to contribute to research, because there is a wide European project called Horizon 2020. And we try to encourage them to go into this direction and propose topics on this on EAC. We will also probably update the MMPDS with some more information on this particular topic. So contact point at EASA. So we are 3 people managing this issue at technical level. So I'm Hervé Cérézon, focal point on this issue, together with Wolfgang Hoffmann. And Simon Weiss is supervising the topic as a senior expert on material, and just defined a strategy for material guidance update. And Richard Minter is also the chief expert that has oversight the whole topics as well, and the continuous awareness activity. So I didn't mention his name here, but I will update the slide accordingly. Thank you very much for this, your attention on this presentation.
So Erdris, thank you very much. It looks like you were saved by your very good presentation, so that no one has questions on environmental acid cracking for the moment. So you can go if you want to. Oh, wait a moment. Thank you, Mr. John Daniels. Can case studies be provided of specific EAC examples?
For the moment, it's quite delicate to share proprietary information on this topic. First of all, the concerned TC holder do not necessarily want to make a publicity on this topic. Second of all, we at EASA, we are not entitled to share information or design that wouldn't be standard one. So this is why we can provide, let's say, a basic example on how the crack develops, but we cannot tell you who is concerned, which part are concerned and affected. But I think from the presentation and the examples I provided, you can figure out pretty well which kind of structures are concerned. So when I say thin plates, when I mentioned, let's say, frames, stringers, this kind of parts are most of the time in aluminium. So the most important is to understand if you have this, if you encounter this material, to understand that you have to do more investigation on the material, or simply just select another one.
These are the 3, certainly with the 3 elements combined: material, the environment, and the ST loading.
Yeah, exactly. So the environment, you will operate anyway. I mean, airplanes are on airports saying hours in very hot conditions, humid conditions, taking off, you have condensation. So the environmental condition, you will have them anyway. After, what you need to check is the short transfer direction and the material designation.
We have a question here. You can see which states: will agency consider to put EAC risk management topics into CS25 for initial airworthiness point of view? So making a difference between the integration of new requirement in CS25 compared to the ESIB. Is the ESIB enough? This is a question.
Okay, so today, basically, in our requirement, we have 613, 603, 613, and 601 for experience, adverse experience. 613 and 603, it's about material properties and characteristics. So this topic has been also encountered at this stage because maybe enough investigation has not been into the short transfer direction because it wasn't the predominant direction for crack. What people were looked at is the benefit in fatigue that those materials were actually offering, which was very interesting. So basically, this is resulting from a lack of investigation on the material properties. And let's say that everybody missed it because it was so peculiar and so improbable because the 7000 series was never subject of an issue, or at least of a not known issue. It was, I mean, basically, if you cycle them enough, they will crack as any material. They have potentially fatigue capabilities, but they were actually very promising in terms of potential. So I believe today that the requirement has the potential to address those issues because it's high level enough. After, it's the responsibility of the TC or STC holders to make what is necessary to challenge the material capabilities. And this is what we expect as a demonstration of compliance. So I believe that today it is this topic at EASA, at least it has been raised at department level. It has been raised at the executive director level. So, and we presented with Richard Minter how the topic was going to be handled by the most concerned people. So in terms of awareness, it has been done at every level in this agency. And for the risk management ICS 25 level, I believe that everything is actually in the requirement to normally cope with this issue. It's a matter of demonstration of compliance. That was the problem. The SIB, is it enough to raise awareness? I believe yes, because, and not only the SIB, but this type of communication we are doing at every forum. This presentation has been done at the Watercraft STC Workshop. It has been done here. It was done at many opportunities. So I believe that the community is quite aware of this topic. And if not, please share the information. If you know somebody that is not aware and should be aware, please share this information. So yes, we will see also based on the experience we have with the coming years if we need to do more. But the objective of the SIB was to identify who might be concerned. And I think that after the few months or 6 months after the SIB was issued, we had already pictures. When we updated the SIB with a test method, we had all the additional feedbacks. We have met most of the people concerned by this topic. So we believe that we are quite in a good situation in terms of understanding of the issue, understanding of the corrective action. Yes, so, but if you have suggestion on what could be done additionally to that, I think we are also ready to receive recommendations on your side. We are not close to advice.
Thank you, Idris. Do we have Mr. Gabriel Dima? Can you raise your hand? Okay, you have a microphone. It's for the alloys, what you're asking, the list of alloys. So the question is, will or have EASA published a list of non-recommended alloys?
They are in the SIB, specifically. And the list that I have provided on the slide, they are listed also inside of the SIB. So you have a clear understanding of what is concerned.
We have a question from Mr. Hasler. Is this phenomenon affecting extruded aluminium alloys only or forged material as well?
So extruded aluminium alloys are more concerned. Many tests has been done on forged material, but for a reason that's probably linked to the techniques, let's say forged alloys are not always exhibiting cracks. So we consider to be on the safe side when the material is concerned, no matter if you are on extruded aluminum or forged material, it's better maybe to either inspect the material or replace it. So I believe that the forged aluminum give a more regular grain shape than the extruded one, particularly for thick billets. But no matter what, the problem is at the boundary, at the grain boundary. So at the end, with time, it will happen. Even if the forged material exhibits later EAC later than the extruded material, the problem is that it will happen at some point of time. All the question is when. And it's really, the when is depending on the short transverse stress level, on the thickness of the material. It will depend also on the material sensitiveness, because as I said, there is a range. The material with the red spot is very sensitive, while the material with the yellow spot is really at the boundary. So sometimes it's exhibiting EAC, other time it doesn't. So we decided that it was better to recommend to be on the safe side, not being too specific on the production, on the kind of on the shaping of the material and so on. It doesn't brings any contribution.
Okay, a very good question, I must say. I'm sorry there is no name on it, but is this topic only valid for primary structure, or is it valid for any structure that carry loads?
As is a material valid for a kind of structure? No. So basically, I said that this material was interesting because it has good fatigue properties, but it was not only installed on primary structures and PSCs. You have this material installed also on secondary structure. This is why I mentioned I make this presentation today to you, because you need to understand that if you find this material or if you use those material, they might be susceptible to cracking. When it's not on PSC, when it's on secondary structure, you will have cracking, and the consequence will not be problematic, will not bring to an AD, but you will have a reliability issue for sure. So we don't forbid to use those material. This is not the point, because on secondary structure, first of all, if you have the material installed, if you don't have stress in the short transfer direction, probably nothing will happen. So you need to have a certain combination of elements for it to happen. So I would say, I hope not to anticipate something, but if you have secondary structure with no stress in the short transfer direction, you should be fine.
Okay, very quick question here, which Mr. Savas is asking for the SIB number. I don't know, was it in your presentation?
I think it is embedded inside of the presentation, and the number is readable also on the embedded PDF.
Yeah, this is a 2018-04. So you will find it.
Thank you, because I don't remember.
Yeah, I just Googled it, I must say, sorry. I was prepared, so.
And as I say, yeah, you just dial environmentally assisted cracking or EAC, for sure you find this one.
Yeah, a quick search in internet is very, very direct. There was no AD raised, or Ms. Da Costa is asking, was there an AD raised?
So this is a difficult one. So let's say that the first urgent issue was to identify who was concerned, what was the urgency of corrective action. So airworthiness directive will be issued in due time, but airworthiness directive can take too long. So many topics has been managed by anticipation, by monitoring, because we are using as well monitoring in some cases. As I said, it was based on risk, and as it's time related, we know that it's going to happen at some point, but it's not necessarily urgent to ground everything and inspect everything at date one. So most of the people concerned, of the TC holder concerned, they have offered a planning based on risk, based on mostly the most critical part. And upon this planning, a worthiness directive will be issued in due time.
Can you please use the microphone if you have one just right
Because
to your
some
right?
people are-
Sorry, I raised the question. Ana Costa from TP Portugal. So, as an airline, I shouldn't be worried. That's what you're stating.
As an airline, you will have you will have information in due time.
Okay.
You'll have information in due time, and the due time is related to anticipation of the issue.
Okay.
Basically, you will not, I mean, as an airline, I think that everything has been done so that the issue can be coped early enough not to disrupt the use of the airplane.
Sorry, if I can complement the question, who is supposed to contact the airline?
I think that basically, as I said in the presentation, based on the product affected, if it's a certified product, the TC holder has a responsibility to address the issue. So the TC holder will contact the airlines in due time. For the products that are not yet certified, basically, as EASA, we try to raise the awareness during the certification exercise. And for the people that did not apply yet for a type certification and do not have for the product that are not yet into service, we try to do share information by anticipation so that you know what is going on with this material, and probably you might avoid maybe to use them in the future, or do more investigation to understand in which condition you can use them.
So the message for STC holder will be to have a review of the document of the alloys they are using for their structural installations, right?
Yes, the objective is to say to you, when you are doing an STC, when selecting material, you should maybe pay attention have a look at on this list and check if the material you are using are part of this list. But from what I know, STC holders are using quite conventional material, particularly when modifying an airplane or a helicopter or any flying products. You tend to use the very similar material that is actually installed on the structure. So it shouldn't be an issue for STC holders, but in the STC world, you have small STC holder, big STC holder, small alteration, and massive alteration. And this is why we thought, okay, it's necessary for everybody to have the information and to know about this topic, as many general items that can affect several products. So it's better to be informed and aware of the issue than to correct the potential issue.